Data analytics can be extremely useful, especially when dealing with large amounts of data on a day-to-day basis. It helps us gain insights, uncover patterns, and understand the underlying structure of our data. When it comes to data analytics in Python, one powerful library stands out, and it's Pandas. But what is Pandas? Pandas simply is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the Python programming language. With its huge set of functions and easy to understand syntax, Pandas make data manipulation and analysis so much easier. This video aims to explore the top 10 Pandas functions and methods that I believe every data analyst and professional working with data should know. In this tutorial, I will not go into depth on how to install Pandas on your machine, but rather I will be showcasing these important functions through Google Colab, a hosted Jupyter Notebook service that requires no setup to use and provides free access to computing resources. So as I've mentioned, we will be using Google Colab to work and to visualize the top 10 essential functions and methods that, in my opinion, are useful for any data analysis using Pandas. And this is by no means an exhaustive list, and feel free to use this as a starting point to explore more and more functions that you could and methods that you could use in your own toolset. So without further ado, let's get started. And to showcase these Pandas methods, we will be working with two data sets. One that is concerning the Spotify tracks dataset, and the other concerning healthcare dataset that Analytics Video has prepared for their own hackathon. And I've opened it right here. And it's always good practice to rename the data that you have. I will be using an additional of two demo data that I've prepared to simulate some errors that you might find when importing the CSV format of data. And I have these two data sets that I've just mentioned. One, this is the Spotify dataset. So I'll rename it to Spotify. And the other that I will rename to hospital. Okay. And so I can drag and drop or use this this button to import all the data. And so we can refresh. However, you should keep in mind that when working with Google Colab and uploading files over here, when you terminate the session, which is basically terminating or closing this notebook, what ends up happening is this disappears because this is just a temporary storage for you to quickly access the data that you'd like to access while working with Google Colab. A better practice would be to mount your Google Drive and connect to Google Drive and connect and upload your data over there, and then you can easily access anything you have on your drive. First things first, when working with Google Colab, you don't need to install Pandas and NumPy to use them. It's already installed. However, you would need to import Pandas and NumPy, and that's exactly what we did over here. We're importing Pandas as PD and NumPy as NP. And when we're dealing with data, we're usually dealing with different formats of data. So we either would have a CSV file format or an Excel sheet that we would like to import, or even JSON. And the thing about Pandas, and what's so great about Pandas, is that it allows you to import different types of file formats. And two common file formats that I usually work with are CSV files and Excel sheets. And to import any data using the CSV format or in CSV format, you would need to use the read_CSV. And to read anything in Excel, you would need to use the read_Excel. And then, of course, you should always take the path of the file. So let's say we will be using the Spotify_.csv. Copy the path and paste it over here so that you can successfully import that CSV. Now, working with CSV data, we might encounter some issues when importing this data. And the most common issues that I personally faced were either the incorrect specification of separators or encoding issues. So I've went ahead and I've prepared two demo datasets, one that is data.csv with a issue with the separator, and another dataset, data_UTF-16BE, is another dataset to simulate these common issues that I personally encountered multiple times, and how to go about solving these issues. So when we have a dataset with a separator that isn't specified in the read_CSV, this is what we get. So when I open this data.csv, I will notice that each entry is separated by a semicolon. And the default for the read_CSV is that it assumes that the separator is a comma. And to solve this issue, we would need to use the sep and set it to the separator in place. So in this case, it's the semicolon. And so when I go ahead and run this, I get a proper way of visualizing this data set. Another issue is the encoding. So I've used the same data set, but in a different encoding. And it's also separated by a semicolon. So that's exactly what I've specified while reading the CSV. However, when running this, we get this issue, an encoding issue, a decoding issue actually. So what I need to do in this case is specify the encoding type. And here, since I'm the one who've prepared the data set, I've prepared it in this type of encoding, and that's exactly what I did. I specified the encoding type, and while running it again, I successfully import the data from the CSV file. To preview any data frame that you're working with, you can use either .head or .tail, and we've already seen this above when we were visualizing the different issues with CSV file and importing CSV files onto your Google Colab notebook. So we could do that through calling the data frame and .head to visualize the head of the Excel or the CSV file that you have, or your dataset or data frame. And basically what it does, it just shows the first 4 to 5 columns, 4 to 5 rows of your dataset. And it's really great to look at and visualize the different columns and data available. And if you'd like to visualize the end of your dataset or data frame, and data frames are basically like a spreadsheet, and it contains columns and rows of data. So when we visualize the tail of the data frame, we will get the exact same output, but rather than the first and second and third and fourth entry, we will be getting the last 4 to 5 entries of the data frame. And another way we could name these columns and call them are features. So this data has different features. It has different columns to describe it. So we're talking about Spotify, and we have different features or columns that describe Spotify. We have artists, we have album names, track names, popularity, etc. So when we hear the word feature, we're usually referring to columns. Now, another important way of understanding our dataset is to describe it through the method .describe. And by just calling df.describe, we can get the description of statistical, let's say the statistical description of our data. But by default, the .describe only looks at the numerical data if you have a data frame with two types of data, meaning that if you have a data frame with numerical and categorical data, the .describe will by default take a look at only the numerical data and provide you a statistical summary for your numerical data. And as you can see, the statistical summary encompasses the count, how many entries do we have, or how many rows for each column do we have. So we have about 66,000 entries for all, or rows for all the features or columns. What is the mean value of these numerical data in each column or feature? What's the standard deviation? What's the minimum? What's the maximum? What's the 25th percentile? What's the 50th percentile? And what's the 75th percentile? However, if we have a series or a data frame that has categorical data, for example, a series that has different types of fruits and vegetables, and we call the .describe, we could see that there's another way that this method describes categorical data. It describes it in a different way. We don't have a min and max for categorical data. We don't have a min and max for different types of vegetables and fruits, right? So the way the .describe method works for categorical data is that it describes its count. How many entries do we have in a series or a data frame, or different columns in a data frame? How many rows do we have in different columns in a data frame? How many unique values do we have? And when we count the unique values that we have in this Pandas series, we can see that we have 1, 2, 3, 4, 5, 6, 7 unique values. I've added this to the Pandas series, and that's exactly what we get, a unique value of 7. However, when we, for example, change the way we write these entries, so we know that this is a unique value, right? We know that this is one unique fruit or vegetable. That's one unique entry to the Panda series. But since this has a space right in front of it, it can totally change the number or the count of unique values we have in a series. So we must pay attention to that detail. Another thing that it describes is the top value of the series or Pandas data frame. So here we have the top value is apple, and its frequency is that it's mentioned twice. Now, since the .describe by default, when working with a mixed data frame that contains both numerical and categorical data, only focuses on providing us with the statistical summary of the numerical data, we would need to include this into the argument for the .describe method, which is include all. So meaning we need to find all the descriptions for all types of data available in the data frame. So that's exactly what we'll be doing. Another way we can get insight into our data frame is through using the .info method. And when we keep the verbose to true, we get a very detailed description of our data frame. So we have these columns or features of the data frame, and we have the non-null count as such. We could see that from the non-null count, some of them are 66016, and some of them are less than that. So we have columns with missing or null values. And this is such a valuable tool because it allows us to understand the type of data in each column. So we have objects over here, and we have floats and integers. But a shorter version of the .info method is when we keep the verbose as false. We get the following. We get the number of columns. We have 21 entries. Okay, so the columns start from unnamed 0 to track genre. And we have the following types, data types, the float 64, int 64, and object, and the memory usage. And we have about 66,016 entries. Another useful method for pandas is to find the duplicates of rows or columns in a data frame. And to do so, we can use the duplicated method in pandas. This method returns a Boolean series indicating whether each row is a duplicate of a previous row. And to understand that more, let me call the .duplicated method and see what we get. And that's exactly what we get. A Boolean series indicating whether each row is a duplicate version of its previous row. And for us to retrieve the duplicate rows and print them out, we can pass that into the data frame as such. And then we get nothing, since all of them are false values. Now, what if we wanted to do that same exact thing, but rather than looking at the whole data frame, row by row, we want to zoom in into a specific feature or a specific column and find the duplicate values of artists, and not just as a Boolean series. No, we want to also print out those artist names that are duplicates of each other, or duplicate rows of the row above. And we could do that by getting the duplicate for the column artist and passing that Boolean series into the data frame of the column artists. And when we print that, we get exactly that. But what if we wanted to do something more complex? For example, find the track IDs of those artists with duplicate entries. We could simply replace that with track IDs. Let me make sure that the name of the column that I'm using is correct, and go ahead and print that. And that's exactly what we get. We get a list of the track IDs with duplicate artist names. If you're interested, this video is based on a Medium article that I wrote, which I will link in the description below. In the next video, we will be looking at how we could find missing values using pandas and the different ways we can deal with those missing values using pandas as well. So stay tuned, and thank you for watching.